The question is given utility function as utility is a function of two goods x and y, which is equal to x plus 2 times y plus 1. Price of good x is $4, price of good y is $6, and income of the consumer is $130. We need to find out the consumption optimal bundle, rather optimal consumption bundle in this case. Okay, so this is actually the maximizing concept. We want to maximize the utility of the consumer, which is being given by, so we have x plus 2 times y plus 1 subject to the budget constraint. That is, what will be the budget constraint? That will be price of x times units of good x plus price of y times the units of good y should be equal to the income of the consumer. Okay, so can we rewrite the utility function as? So let us solve it first. So we have x plus 2 times y plus 1. So can we rewrite it like this? So multiplying first with respect to x, so we have x into y is xy, then we have x into 1 is x, then we have 2y plus 2 ones are 2. So our utility function is xy plus x plus 2y plus 2. Okay, graphically what exactly is meant by this? So let me be within the limit. So you get x on the horizontal axis, good y on the vertical axis with the given budget set. So we have this given budget set, and specifically we are being given, so we have price of x is 4, so we have 4 times x plus price of y is 6, so we have 6 times y should be equal to, we have 130. Okay, so dividing both sides by 2, so we get 3x plus, rather 2x. Okay, so dividing both sides by 2, we get 2 2s are 4, here we get 3y is equal to, so here we get 2 6s are 12, then we have 2 5s are 10. Okay, so with the given budget set, consumer want to reach highest possible satisfaction, and optimal bundle will lie at a point where the indifference curve and the budget line are tangent to each other. So at this point what happens, our marginal rate of substitution between good x and y should be equal to the ratio of the prices, price of x upon price of y. So this denotes the slope of the indifference curve, this ratio denotes the slope of the budget line. So MRS, as we know, it is simply the ratio of marginal utility of x, good x, upon marginal utility of good y, and it should be equal to px upon py. Px is 4, py is 6, so we have 4 upon 6. Then marginal utility of good x is simply the change in the magenta. So let me use another color. The change in the change in the total utility due to the change in the consumption of good x, that is marginal utility of good x, divided by marginal utility of good y, means the change in the total utility due to the change in the consumption of good y. 4 upon 6 can be written as 2 upon 3. Okay, which implies du upon dx means the derivative of this function partially with respect to x. Derivative of x is 1, so we are left with y, plus derivative of x in the second term is 1, and derivative of the last two terms is 0 because we are taking the derivative with respect to x, divided by we need to partially differentiate again with respect to y this time. So derivative of y is 1, so we are left with x, plus derivative of x is 0 because we are taking partials with respect to y. Derivative of y is 1, so we are left with 2, and derivative of a constant, we know it is equal to 0, and we equated with the slope of the budget line. Doing cross multiplication here, we have 3y plus 3 is equal to 2x plus 4. Solving for y, so we get 3y is equal to 2x, transpose it here, it gets subtracted, we get 1 only, or y is equal to 2x plus 1 upon 3. Now we plug this value into the budget constraint, so we get 2x plus 3, the value of y is 2x plus 1 upon 3 should be equal to the income of the consumer. 3 and 3 gets cancelled, so we have 2x plus 2x, so we get 4x plus 1 is equal to 65, which gives us 4x is equal to 64. Transpose it here, it get a subtract. Dividing both sides by 4, x will be equal to 4 ones are 4 even 4 6 are 24. So optimal consumption of good x will be 16. So we have 16 here. What about optimal consumption of good y? Plus x is equal to 16 into this function. So y will be equal to, so we have 2 into 16 in place of x, we substituted with 16 plus 1 upon 3. So sharat sharage 32. So we get 32 upon 3, rather 32 plus 1 upon 3. I am not within the visible range. So we have here 3, here we have 3, that gives us y will be equal to 33 upon 3, which is equal to 11. That means optimal consumption bundle, that is x star y star, will be equal to 16 and 11.